it is not possible to produce perfectly smooth surface, and always there are some irregularities, which is called as roughness on the surface. And these irregularities create some difficulties when using the components, because of which wear and tear of the parts takes place. Therefore, it is very important to correct the surfaces after the measurement of the surface finish. There are some factors which are responsible for the surface roughness. The most important is workpiece material, vibrations, type of machining, and tool and fixture. In workpiece material, if the material of the workpiece is hard, then it will not be machinable, and because of that, some roughness will be produced on the surface. Second, vibration. Vibrations are mainly responsible for the surface roughness. And type of machining. If you are cutting, depth of cut is high, that is, if your coarse cut is there, then more roughness will be there. And if your tool and fixtures are not rigid and clamped tightly, in that case also surface roughness will produce. Now, type of surface finish. First of all, we should know what is surface. Surface of a body is its boundary which separates it from other body. Okay, there are two types of surfaces. First is nominal surface. Nominal surface is nothing but it is an ideal or perfect surface, which is theoretically geometrically perfect. Then rough surface. These surfaces has numerous small peaks and valleys that deviate from the nominal surface. Means a surface or actual surface on which peaks and valleys are there is called as rough surface. Definitely these surfaces has a certain degree of roughness. Then wavy surface, as shown in figure, third one, a surface of this type is called as wavy surface. Now, geometrical irregularities. Now we will discuss the causes of the roughnesses. The first is first order irregularities. These irregularities are caused due to lack of straightness of guideways in machines, like in lathe, like in shaper, milling. The guide weights are not straight on which tool is moving. Then second order irregularities, these are caused by vibrations. Then third order irregularities, these are caused by machining, type of machining, whether coarse or fine. Then fourth order irregularities, these are caused by improper handling of machines and equipments. Now, very important is elements of surface textures. A surface have many elements like surface roughness. These are micro irregularities resulting from the action of production processes, as discussed before. And profile, it is the shape of any section through a surface. If we can see the shape, cross section, if we can see, then that will be its profile. Then flaws. These are irregularities in a surface due to cracks, blowholes, scratches, etc. Unless otherwise specified, the effect of flaw should not be accounted in the measurement of roughness. This is very important. Then surface sample or cutoff length. The particular length that is taken for sample measurement is called as cutoff length. It is also known as roughness width cutoff. Lay. It is the direction of the predominant top surface groove that are produced by machining. And final one is the waviness. Surface irregularities that tasting than roughness is called as waviness. We can easily see all these elements on these diagrams. It's very clear. Now, datum for surface finish measurement. For the quantitative measurement, we have to assume a reference or datum from which surface finishes numerical values may be specified. There are two methods for that. One is M system, that is mean line system. In mean line system, it is a line that is parallel to the general direction of the profile and is placed such that areas around the profile above and below the line are equal, as shown in figure. Then how the mean line is determined? Mean line is determined as follows. A straight line AA is drawn so that it is parallel to the general direction of the profile for a length L. Then area and x and y are measured as shown in figure. The mean line BB is a line of distance C from line AA, where C is calculated using area x, summation of area x minus summation of area y divided by L. The line BB is parallel to AA. This is the first method by which we can easily get the numerical values to the surface finish. Then second method is the E system, the envelope system. Envelope line is a line that is obtained by rolling a circle of radius r on the surface. This curve is the locus of the center of the circle. Once this curve is obtained, it is brought down vertically by a distance r. By doing so, the curve will rest on the crest of the surface. Now the envelope curve is moved downward to a position so that area around the surface profiles above the below are equal. This mean envelope curve becomes the mean line in the E system. Now what we want to analyze the surface finish. The surface finish can be analyzed using these three methods: the average roughness method, peak to valley height method, and form factor. It is form, not FORM, form factor. The first one is average roughness measurement. In this method, following are the values which can be obtained. First, centerline average value, RA, root mean square RMS value, then 10-point method. Now, first of all, centerline average value. This value is average height from mean line of all ordinates of the surface regardless of sign. Let H1, H2, H3 be the height of the equally spaced ordinates of position 1 to n. Then CLA will be equal to summation of H irrespective of the sign, whether it is positive or negative, it will be considered positive only, then divided by total number. Another way of calculating RA is shown in the figure by using areas above and below, and both will be considered as positive. Second is root mean square value RA. It is the square root of the mean of the squares of the surface measured from the mean line, as H1, H2 are the heights of the equally spaced coordinate position. Then what we will do, we will square all the ordinates, then we will sum them and divide it by n, and then only we will take the root of this. This is RMS value. And 10-point height method. In this method, the average difference between 5 highest peaks and 5 lowest values of surface is taken, and irregularities are calculated using following formula. All the 5 highest peaks will be added, then all the lowest values will be added, and then the difference will be taken, and then average of that will be taken. This is called 10-point height method. The next method is peak to valley height method. It is the distance between the highest peak and the lowest value for the considered sample length. L is the sample length. This is called as peak to valley height method, R max. Then form factor method, it is obtained by measuring the area of material above the arbitrarily chosen baseline in the section and the area of the enveloping rectangle as mentioned in the last two slides. Degree of fullness will be equal to metal area upon enveloping rectangle area, and degree of emptiness will be 1 minus F. The depth of smoothness, it is a distance between the mean line and another line that is parallel to its drawn such that it touches the highest peak within the considered sampling length. Then the mean depth, it is the distance between the mean line and the another line that is parallel to its